Hi guys, welcome to mathematics. In this video we want to solve for a in 4 raised to power a plus 8 raised to power a equals 26. That's a solution. But wait a minute, can you solve this before I do? Alright, so you can actually solve it and comment your answer. Alright, so you can move. We have 4 raised to power a plus 8 raised to power a equals 36. So from here, you can express this as 2 raised to power 2, right? So raised to power a, then 2 raised to power 3 raised to power a equals 36. All right, but don't forget that you have x raised to power m raised to power n is equals to x raised to power n then raised to power m, right? So that means that we can have this becomes 2 raised to power a raised to power 2 plus 2 raised to power a raised to power 3 equals 36. So from here we can do something interesting by letting our 2 raised to power a equals k. Let 2 raised to power a equals k. So and if we do, we have k square plus k raised to power 3 equals 36. So if we rearrange this according to their increasing power, we will have k raised to power 3 plus k raised to power 2 minus 36 equals 0. So looking at this equation, raised to power 2, you observe that this is a cubic polynomial, right? So then if you should solve this, so there are ways to solve this actually. So but one of the finest way I will tell you is to just find a factor that what number, so just like a triangle. So what number can you substitute into this to make this equal 0? So but you can just try 3. Let k equals 3. So now let's see, we have 3 raised to power 3 plus 3 raised to power 2 minus 36 equals 0. So here we have 27 plus 9 minus 36 equals 0. So we have 27 plus 9, so that is 36 minus 36 equals 0. So it works. So we have this equals 0. So therefore k minus 3 is a factor. So you get, so now let's use long division to obtain other factor of this equation, right? So let's use the long division. We have k minus 3 here. So we have the equation, we have 3 k raised to power 3 plus k raised to power 2 minus 36. Now let's watch this closely so you don't make a mistake. K in k cube, so we have k. So k square, so use this to multiply this. We have k square times k, we have k raised to power 3, then k square multiplied by minus 3, so that is minus 3 k square. So now we subtract this. If we subtract this will cancel this. We have k square minus times minus, that is plus, so that is k square plus 4 plus 3k square, that is 4k square. So then you bring down this minus 36 here, right? Again, this can still divide this, k in 4k square, so that is plus 4k. So use this to multiply this. So we have 4k times k, that is 4k square, 4k times minus 3, so that is minus 12k. Again, subtract this. If we subtract it, we are going to have this cancel each other. So we have minus times minus, that is 12k. So then bring down this constant, so minus 36. Again, we can have k divided k going into in this. So we have, how many k can we see in 12k? So that is plus 12, right? 12 times k, that is 12k. 12 times minus 30, so that is minus 36. So if you subtract this again, you observe that you have 0, right? So that means that for k cube, factor for k cube plus k square minus 36 equals 0 is what? Is k minus 3, right? Multiplied by k square plus 4k plus 12 equals 0. So this implies that k minus 3 equals 0, or k square plus 4k plus 12 equals 0, right? So from here we'll have k equals 3. So this is one solution, and you can name this k1, right? So here, let's see this. We have delta. We know the delta is equals b squared minus 4ac, right? So this is equals, what's our b? 4, right? So we have 4 squared minus 4 times 1 times, what's our c? That is 12. So we have this delta equals 16 minus 4 times 1, 4 times 12, that is 48. So you observe that this delta is what? Is negative. So we have to reject this. So we have to proceed with k equals 3, right? So we want to take k to be equals 3, right? So, but we are not asked to find k, right? You know, so we have to find a, and to do that, we say recall that 2 raised to power a equals k, right? So we have 2 raised to power a equals 3. So introduce log on both sides. So we have log 2 raised to log 2 raised to power a equals log 3. So from the law of logarithm, this a will come forward. So we have a log 2 equals log 3. So we can divide both sides by log 2 and this by log 2. This will cancel this, right? So we have a equals log 3 divided by log 2, right? So but let's recall that if you have log x divided by log y, this is equals log x and base y. So applying this to the above, we say we will have a equals log 3 and base 2.